Molecular diffusion, often simplified by diffusion, is the movement of all of the particles at a temperature above absolute zero. The speed of this movement is a function of, for example, temperature, fluid viscosity, and particle size. The importance of this property is that it is currently applied into multiple areas of industry. In this case, we are going to take as a reference an example of a boron diffusion into a solid crystalline silicon wafer that will help us to understand better this concept that sometimes is very abstract. As a first step, we must establish the diagram of the process that it is shown in the presentation. In the manufacture of a semiconductor, the boron has to be in a small distance of the solid crystalline silicon wafer. As you can see in the diagram, the concentration of the boron at the surface of the system remains constant, since the total of the concentration of the boron present in the surface is equal to 1 in a time of 30 minutes. The objective of this problem is to determine at which temperature the boron has to work. This is because the diffusivity and the temperature are closely related. Now we move into the transport model. For this part, we have to establish the transport method, and then we must establish the balance of the sheet of matter. Assuming that the process that it is found on a steady state and has no reaction, the equation can be simplified as follows. With respect to a fixed law, we can establish that our system is a fluid that it is solid and static. We also have the diffusivity of the rate of boron is a dilute solution that we can represent as follows. The next step for resolution of the system is the combination of the mass balance equation with fixed law equation. Here is the error function, and with this information we can compute the depth of time of variation that it is 0.2 micrometers. Then we can substitute the values for 1.5. From the Arrhenius formula, we can compute the temperature that the boron has to be to the process that can be operated. Once we have the value of the diffusion, we can obtain the value of the activation energy, and that can also help us to change the values that remains constant, and with this we can have the temperature that the boron has to be operated. And with all of this process, finally, we can have that the temperature is 1204.13 degrees Celsius, that it is the temperature that we have to be able to put in the process